Ladies and gentlemen, we are now moving to our first session, focusing on future-ready power grids, practical solutions for grid modernization. India's power distribution sector is evolving with the rise of renewable energy sources. Grid modernization presents an opportunity for improved reliability and efficiency. The Aspire program highlights key smart power initiatives for adoption. This session will explore the ecosystem dynamics and imperatives for stakeholders in scaling up smart grid technologies. I would like to welcome Ms. Cathy Chen, Associate Director, KPMG UK, who will join us virtually today to present a case study based on Aspire program initiatives. Over to you, Cathy.
Good afternoon, everyone. It's a pleasure to speak with you today, and I really wish I were there in person, but unfortunately you have me virtually. I am presenting, I'm going to be sharing my screen, so I'll be speaking to a few examples from the UK, building on the Aspire program that I had the pleasure of implementing with the FCDO and my team in India, KPMG India. My role on Aspire has been to provide technical oversight as well as facilitate the investment in commercial partnerships work package. So without further ado, I'm sharing my screen. So today's conversation, there will be a panel discussion shortly following this presentation. And so I just wanted to set the scene a little bit with an overview of the UK's grid challenges and policies. As some of the speakers mentioned earlier, there's shared opportunities to modernize the grid between the UK and India. So let's get into that a little bit in more detail through different technological advancements and grid management strategies. I'll also do a little bit of a deeper dive into interconnectors, and then wrap up with some key takeaways and opportunities. So the UK's grid infrastructure is currently under pressure due to increased demand and the need to integrate more renewable energy. As a grid that has been structured and designed for more traditional energy sources, there is a need to modernize the ability to handle new technologies and integrate more demand flexibility services as well. So therefore, the UK is pursuing investments in different technologies, including interconnectors, expanded transmission networks, and smart grid technologies, which I'll cover in the next slides. Currently, renewable energy projects face delays of up to 10 years to connect to the grid, with over 1,700 renewable energy projects in queue. And this is because of a first come, first serve policy. However, the government is planning to change this to a first ready and first connected framework, which means that shovel-ready projects will be connected before any of the other projects that are in queue. So this will aim to streamline the approval process and then ensure lower delivery delays, essentially for integrating renewable energy. The UK government has also implemented different policy initiatives, including a Plan for Change initiative, which aims for clean electricity by 2030, set to fast-track grid connections for clean energy projects. This is also complemented by a planning and infrastructure bill recently announced that aims to unlock £200 billion in investment for new transmission infrastructure. And this includes accelerating decisions on offshore wind, electricity grids, hydrogen, carbon capture, and nuclear power stations. This approval process aims to be more streamlined by reducing the consultative burdens and making sure that engagement is focusing on efficiency and reducing duplicative measures of consultations. The National Energy System Operator also has a report where it recommends certain upgrades to the grid, including increasing offshore wind integration of around 21 gigawatts, and a network that has 3 times more undersea cabling than onshore infrastructure by 2035. So what are the different sources of technological advancement? So on smart grids, as many of the speakers mentioned earlier, there is increasing use of AI, IoT sensors, and smart meters to improve real-time demand response capabilities. For example, condition-based monitoring using sensors is one of the means to maintain and operate the grid efficiently. NISO is implementing virtual power plant projects to this effect, and then looking at the use of AI and distributed energy to stabilize the grid in real time. And under Aspire, we have developed a case study as well on drone and AI-based asset management solutions for electricity distribution utilities. As mentioned earlier, this included sort of methods of remote sensing and diagnostics, using digital capabilities to reduce dependence on manual labor and maintenance. And we'll be hearing from Vidrona, actually, who was implementing this with the Maharashtra State Electricity Distribution Company. So very pleased to be hearing about that on the panel discussion later on. We also have a lot of battery storage and grid-scale battery solutions in place to kind of address the variability of renewable energy. For example, looking at the Pillswood Battery Energy Storage System in Yorkshire, it's actually the UK's largest grid-scale battery storage facility, which is helping to manage fluctuations from offshore wind electricity. And there's also Cetera Energy, which has acquired a 680 megawatt battery energy storage system, which is set to be the largest of its kind in Europe, once it's fully operational in 2026. The UK has also been implementing pumped hydro storage for longer duration energy. And some examples include a power station, Dinnerwig Power Station, located in Wales, which has a pumped hydro storage of approximately 1,700 megawatts, making it one of the largest pumped hydro storage plants in Europe. In terms of dynamic grid balancing and demand side management, this is all about shifting demand to help balance the grid, understanding the customers, users of energy, and implementing behavioral economics. And as speakers mentioned earlier, there's different means to do this. One way is through policies and incentives such as time of use tariffs and smart metering. There's a demand flexibility service that was trialed in the UK. It's a voluntary initiative that incentivizes consumers to shift their electricity usage to off-peak times, which helps to smooth out the demand and spikes and reduce the need for additional, often fossil fuel-based power at the highest, busiest periods. By encouraging smarter energy consumption, the idea of this demand flexibility service is to maintain grid stability and prevent power cuts during periods of peak demand. We also are going to be hearing from Flock Energy, a UK company that is leveraging the power of smart meter data to encourage behavioral change among energy users to increase energy efficiency. They have an AI-powered solution for behind the meter meant to forecast demand and manage the grid as a result. And under Aspire, we are pleased to have facilitated several B2B connections between Flock Energy and various Indian companies. And last but not least, multi-purpose interconnectors is emerging as a way to structure hubs of not just interconnectors providing transmission capability, but essentially these are hubs that enable energy exchange, provide ancillary services, and serve in terms of cross-border electricity trading as well. And the examples that I'm providing here include the North Sea Wind Power Hub, which is a multi-purpose interconnector project that aims to connect the UK with Denmark, Germany, and the Netherlands through offshore wind farms. And then there's also the Iberian Peninsula interconnector that is being proposed, which will connect the UK with Spain and Portugal, again, optimizing grid stability here. So just to dive a little bit into the topic of interconnectors, as mentioned earlier and in the report launch, we have been exploring under Aspire how different lessons learned and best practices from the UK could be applicable to India. And then in terms of the UK context, so where the UK has strong capabilities in interconnectors is the fact that it has currently 5 operational DC interconnectors, and it's planning to add more by 2030. And why is this important? Well, actually, the UK is one of the leaders in DC interconnectors, especially in the number and capacity of its DC interconnectors. And compared to AC interconnectors, these DC interconnectors are more reliable for longer distances. And these links, these interconnectors, facilitate the import and export of electricity and enhance energy security and balance renewable energy generation. The map here illustrates the various planned and commissioned interconnectors that are connecting the UK to different European countries. And so I think most of you know a little bit about interconnectors, but under Aspire, essentially, we supported the CEA with developing a framework for reviewing the UK interconnector projects and facilitated discussions with various UK stakeholders and grid operators as well as organizations in the wider supply chain to better understand what are some of the transferable lessons learned and best practices. And these included policy measures. For example, the cap and floor mechanism, which is meant to balance investment returns and protect customers from excessive charges, was explored as well. Business models and ownership structures for consideration. In the UK, third-party management of interconnectors is a unique approach that aims to enhance efficiency through private sector operations and reduce costs while ensuring government oversight as well. Procurement and supply chains, exploring those issues early on is important. Engaging with suppliers early on is important because of the lag as well in supply chain and different components. Competitive tendering can encourage specialization of different parts and then increase cost efficiency through structured tenders. In terms of manufacturing design and deployment, of course, cables need to be designed and assessed based on the route, the seabed, the capacity, the depth, and the cost. Going forward, the UK is looking at developing new technologies.
Hello. Hi, Cathy. In the interest of time, can you please wrap up in the next 1 or 2 minutes?
Yep,
Yeah,
will do. So the UK is developing deeper sea interconnectors, which is relevant for India because currently deep sea cables are suitable for up to 3,000 meters. But in some areas near India, the sea levels are below 3,500 meters. And so we know that more technological innovation is needed, and there's an opportunity there to jointly explore R&D on that front. I won't go further into interconnectors, and I'll just wrap up with my final slide, which is just to tie everything together. So why are interconnectors and why are various mechanisms in competitive auctions important? It's through increasing the affordability of energy to the end users. By arbitraging the electricity prices, interconnectors help facilitate this, and likewise through offshore wind auctions, this helps to maintain a competitive price for electricity. Public-private partnerships are important for grid modernization. For example, the UK is collaborating with many companies in smart grids, demand-side management, demand response, to basically incentivize shifting demand and doing it through different market-based services. Also mentioned interconnectors and third-party management, R&D and innovation through government-funded programs, such as the UK's Flexibility Innovation Program, are critical as well because they look to explore what are the biggest future bottlenecks in the grid and looking at how do you incentivize innovation to address those challenges. Example is the Vehicle to Grid, so V2X innovation program under this package, which addresses barriers to bi-directional electric vehicle charging into the grid. And last but not least, risk sharing and financing mechanisms are something to explore further as well, given that the UK is one of the leaders in green bonds, for example. The UK issued the world's largest sovereign green bond of £10 billion, and this has helped to finance different grid infrastructure projects. There's also the use of loan guarantees to help de-risk for private investors into grid infrastructure. And so a lot more ideas there to take away. And for now, I'll conclude here and look forward to the panel discussion. Thank you.
To begin with the session, I would like to invite our esteemed moderator, Ms. Sanyukta Dasgupta. Sanyukta is a senior advisor in the Smart Power, Climate and Energy team at the British High Commission. We are honored to have with us our esteemed panel members who bring a wealth of experience and expertise. Please welcome on stage Ms. Kumud Wadhwa, Chief General Manager at Power Grid Corporation of India. Mr. Kamalpreet Vadhavan, Dr. Ashutosh Natraj joining us virtually, and Mr. Ankur Sharma, Chief Executive Officer, Flock Energy. Over to you, Sanyukta. Let's delve deeper into the world of smart grids and innovative solutions.
Thank you so much, all the panelists and all the distinguished guests today. I know we have been running a bit late, so we'll try and make this as fast as possible. It is my pleasure to welcome you in today's panel discussion on future-ready grids. Just to give a context here, India's energy landscape is transforming rapidly, driven by ambitious renewable energy targets, increasing electricity demand, and of course a need for sustainable, energy-efficient power grid. The country has a target of 500 gigawatts of non-fossil capacity by 2030 and a commitment to achieve net zero by 2070. The challenge here now lies not just in generating this clean energy, but also integrating this renewable energy back into the grid. A future-ready smart grid is the backbone of this very transition. Now, if I have to ponder over the question on what exactly is a future-ready grid, smart grid rather, and I'm sure my esteemed panelists here would be talking about it when their turn comes, it is a resilient grid which leverages digital technologies, automation, AI-driven analytics, and real-time monitoring to optimize electricity distribution, enhance grid resilience, and empower customers with better energy choices. Power utilities across the globe, especially in the West, they are already adopting these smart technologies and they are helping them in meeting their sustainable development goals and also at an affordable cost. By integrating solar, wind, storage and EVs, energy storage and EVs, India can also build a dynamic and adaptive power system capable of handling fluctuations in supply and demand, thus ensuring an round-the-clock power to all its consumers. Of course, this vision requires modern infrastructure, robust policies, grid flexibility, and investment in cutting-edge technologies. Challenges like transmission bottlenecks, storage solutions, cybersecurity of the grid, and regulatory framework need to be addressed. By bringing together veterans from the energy ecosystem, today we aim to uncover actionable strategies to make India's power grid smarter, more resilient, and future-ready. So thank you all for joining us today. I'll start with Kumud ma'am. So ma'am, PGCIL has led the adoption of smart grid technologies in the transmission sector with several examples to your name, such as the first ever fully digital 400 kV substation and incorporation of analytics and AI/ML for predictive maintenance. So if I may ask, it is always difficult to be the first starter and bring about new generation changes such as AI/ML, digitization, cyber technologies and things like that in the grids, be it in the transmission segment or in the distribution segment. So in this context, what insights can you share from your experience on overcoming this inertia to implement large-scale technology upgrades in the distribution sector?
Thank you, Sanyukta. Yes, you rightly mentioned that Power Grid is one of the leading companies which has implemented advanced technology to manage the grid. And in fact, we can really boast that we are managing one of the largest grids in the world and without any grid disturbance in last so many years. And the adoption of technology goes as far as almost 2 decades when we started implementing SCADA systems for managing our transmission grid. So those SCADA systems have helped us to analyze the real-time power flow on the transmission lines, and then accordingly the grid manager were taking actions to control the flow in a manner that the grid disturbance was not at stake. When that process was manual, there were challenges. But then there was an introduction of a control mechanism in the form of availability-based tariff, wherein the distribution companies which were deviating from the scheduled drawal, which was decided in a day on a 24 advanced basis. So if they were deviating from that withdrawal pattern and the frequency was an indicator of imbalances in the grid, so they were penalized or incentivized depending on the scenario at that moment. So a control mechanism was also introduced in addition to the situational awareness, which was analyzing the power line flows in real-time basis through SCADA systems. Similarly, if we need to adopt the large-scale technology interventions for distribution grids, first we need to identify what all are the pain areas. And as we are going to go for large adoption of distributed generation in our grid, So the distribution grid will no longer be a passive grid. It will be active grid wherein lot of generating nodes will be there. And we need to similarly manage our distribution grids almost at par with the transmission grids. We need to figure out what all generation is coming from the distributed generation resources and how do we control during the times of surplus maybe, or during the peak load when solar is also not there but the demand is also high. So we need to have flexible tariffs like Laura mentioned in the earlier session, and those flexible tariffs really need to be flexible. We cannot decide a year in advance that time of use tariffs will be there which will be from such and such time to such and such time, because it will also be dependent on the weather conditions which will be different in different parts of the country. It will also be different in different demographic setups, like for city urban areas it will be different pattern, for villages the pattern will be different. So there are lot of flexibility in tariff as well as flexibility in regulations will also be required if we are to really go for managing our distribution grids with large technology interventions in an optimal manner. We can always go for big bang adoption, like we can adopt it, but we can derive maximum value only if we have that flexibility in the regulations as well as in other parts of the ecosystem. So that is one thing. Another critical aspect is to assess the preparedness. Just because some advanced technology solutions are available and are adopted by the other parts of countries in the other part of the world, we need not to adopt it as is in a similar manner. We first need to assess our preparedness, how much prepared we are, what is the data availability, because garbage in, garbage out may be there. If we are not able to control the quality of data that is going to train our algorithms for advanced intelligence or machine learning models, so we may not get the right result. And we need to buy in the trust of the stakeholders. So for that, first implementation itself should be giving them some value addition and confidence itself, that the technology is going to serve us in a manner to ease out the pain which they are really facing in managing the distribution grids. That was the second aspect. Another point which is very important is for distribution sector, ultimately Laura also mentioned customer is king. About 2 decades back, I got to know a different definition of customer, which was kasht se mar. Kasht se mar means to die by trouble, kasht se mar, trouble to death. So that was the definition in those eras because it was a supplier side market. But now the market scenario has changed and now we are different because customer is now demanding, and our government's motto is also to serve the customer in an optimal manner. So we must check for the pain areas of the customer also. We should be open to the feedback, like if we have deployed some technology solutions and they are based on artificial intelligence, but somebody should be supervising whether it is going in the right direction or is there some deviation. So corrective actions should also be taken simultaneously. These are, I think, my 3 points which I mentioned on this.
Thank you so much for your insights. So 3 areas: pain area identification, flexibility in tariffs, and flexibility in regulations. With that, now I'll move on to Dr. Ashutosh, who is joining us virtually today. So Dr. Ashutosh, we have been engaged together for a very long time under the Aspire program. Globally, you have assisted multiple utilities through their technology adoption life cycle. In India as well, you have assisted a key utility in adoption of drone-based AI-enabled assist management services, something which we have done under Aspire as well. So an issue which we often see here is the long gestation period, that is the timeline from proof of concept stage to large-scale adoption of a technology. In your view and experience, what interventions at the policy or regulatory level could be brought to streamline this process? Over to you.
Thank you, Sanyukta, and definitely, I mean, it's a very good question. And as you very correctly highlighted, that the projects that we have engaged together under the Aspire program with MSC DCL, which is one of the world's second largest DISCOM in the world. And to address the question that you have asked, like, how the prolonged timeline from the proof of concept to the large scale implementation in India, like what are the challenges or the things that we see? Let me cite it in an example in one way. As you would recall, that during our project, we did one part of this entire thing was the asset mapping of the NSCDCL assets. Now, the challenge was that they have seen the drawbacks on the older technology that we have already highlighted, that the new technology that we provided under this project, that helped them quite significantly, but that was still a part of proof of concept. Now, the regulatory aspect that was there, that becomes quite a challenge for them, because the funding, for example, of these kind of projects have been monitored by the regulators to look at. And they say that, okay, they have only a fixed budget, which is allocated as per the older, the costs of the funding that has been allocated for older technology. Whereas now the need has changed, because India is no more a country where it was as we all have an esteemed guest speakers have mentioned about, the energy hunger country. Now it's a very big country in terms of the energy demand that is going. So to address that, we need to migrate onto a newer technology. As we have proven on POC-based solutions, then it needs to be provided. So that's why if I want to pinpoint to certain, just to say certain things that come to my mind, I would say that regulatory simplification and centralization is very important, as Mrs. Kumud Vadra also mentioned here, that sometimes it is important that streamlining of certain things have to be there, and monitoring to see what things have been changed. So it needs to be a more unified digital regulatory authority that should be monitoring these kind of things, like how it is going to impact long term. The other thing would be more like a tiered compliance framework should be adopted by the regulators. So the regulators should be in line with the utilities to ensure that they are able to do this. Secondly, I would say that for the financial and the infrastructure support, that should be there. So as the previous speaker, Cathy Chen, did mention about the risk sharing models, those kind of things also should be brought into the place. Then the other thing I would say is about the more standardization in the data governance, etc. But last but not the least, it's very important to focus on the procurement reforms that the regulators should also focus on, because what we have seen that eventually when the utilities, as Mrs. Kumud Vadra also mentioned, that every utility might have a different challenge. It is not necessarily that what has been a challenge for one utility might not necessarily be the same problem for the other one. So, but then in that case, what happens is that when procurement goes on just based on the simple bidding process, it should be more on the impact-based selection, whereas over the lower bidding processes. So that way, the requirements and the needs of the utilities are addressed directly. So I think these are the typical gaps that needs to be fulfilled. So that will enable to streamline the gap between the timeline from the proof of concept to the large-scale adoption in India. So these strategies would definitely help.
Thank you so much, Ashutosh. Basically, to summarize it, utilities should be in line with the regulations, and also you talked about financial support and road standardization, and of course the procurement reforms. We have another British firm with us today, Flock Energy, Mr. Sharma from Flock Energy. Your organization is a key technology service provider to the utilities in the power sector. What has been your experience with the utilities and the ecosystem around it in the context of technology adoption? Do you see adequate avenues for the technology service providers engaged with DISCOMs, and what additional interventions would you like to see in near future?
Yeah, thanks, Sanyukta, and great question. So it's been a mixed bag, to be frank. The ride has been pretty bumpy at times and pretty smooth at times. So I won't say that it's really related to the utility that we are working with, but the person who's sitting in the chair. What has been their adoption or their exposure towards technology? What are the pain points that they consider to be really important from their standpoint? Is the make or break thing when you are interacting with utilities. We have seen that sometimes in various scenarios, people sitting in that chair would be very pro technology and they would be very interested in testing out new things. But at the same time, they would be, there has been bad experiences as well. Just to share a quick experience that we had in 2023 when we came to India. So we were trying to do energy efficiency for industries in the form of demand response and identification of flexibility. And at that time, we had presented to the CMD Rajasthan, all discoms, and his point of view and the point of view of their team wasn't that industries are the golden geese, so to say, for utilities, so they don't want anyone to make them more energy efficient. But earlier this year, we had the opportunity and we actually had the request from the utility, Jaipur utility itself, to actually do the same project now. So I think it's a matter of timing as well, which plays a very critical role. In terms of the ecosystem, I think there has been some great initiatives taken by some not-for-profit organizations, Climate Collective being one, Electron Vibe being another such program, which works towards connecting startups with utilities and creating pilot programs. So that has been a really great way of actually reducing the gap between technology that is being pitched to the utilities and the pilot that is actually being done. Sorry, the other part there were 4 or 5 things that you had asked, so if you could kindly repeat what the other things were.
My question was, do you see adequate avenues for the technological service providers to engage with the discoms? And the other part was, what additional interventions would you like to see in the near future?
Thanks. So I definitely see a lot of potential for technology providers in the utility space, because probably 10-15 years prior, we didn't have the processing resources. The cost of processing was really high. The thing that we are now seeing, this AI thing, wasn't really there. So now is a right time for all the data that is being collected by smart meters or by SCADA systems, and the cost of processing this data and converting it into meaningful insights is really a cost-effective measure now. So that's something which I really believe that lots of startups and lots of technology providers can contribute toward. And like ma'am said, that it's not a copy-paste thing that we can do in this particular space. We cannot just bring a technology from UK and paste it in India. That's not going to work. There's going to be a significant localization that needs to happen, both from business model standpoint as well as from how we are looking at data and how we are ingesting the data and how we are analyzing it. So local aspects have to be taken into consideration would be my final submission. And to the last part, like Mr. Vidron Ashutosh rightly mentioned, there can be regulatory changes which would be really welcome in terms of financial incentives that can be provided to startups. The newer business model and market innovations would only happen if I take an example of demand response or demand flexibility. All of these market interventions would only succeed when there is a financial incentive associated with it. So those kind of regulatory changes that promote newer and upcoming technologies and business and market innovations could be a great way of inducing some changes in the utility sector.
Thank you so much. So just to summarize, basically a localization of technology, financial incentives, and cost is coming down that you rightly pointed out. So these are a few areas which you think would be important in the future as we go forward. We have with us PFC Mr. Kamalpreet Wadhwa today, just to get some policy aspects from you and also on the financial side. So we understand that there are 2 key roles that PFC as an organization plays in the power sector. First, you are the nodal agency for Government of India for reforms, and secondly, as a project financer in the sector value chain. We have observed that some discoms are leading in technology adoption, serving as examples, and others are following. In your opinion, what policy and regulatory enablers should be in place for financial institutions to finance technology adoption projects, and how can this be achieved beyond traditional routes such as government schemes, like we have the RDSS scheme now? Additionally, what type of financing models can emerge for expediting adoption of technologies for future-ready grids?
Thank you, Sanyukta. First and foremost is when you talk about the policy enablers, I think besides the government schemes, the government itself is supporting a lot of policy. These new technology adoptions not just restricted to the grid modernization, but also looking at the aspects like the battery energy storage, then the pump storage projects, etc., wherein we've seen some viability gap funding, etc., being done by the government. And besides that, the government is also incentivizing in terms of the PLI schemes, right? So as to support the anybody who would want to have a project with respect to the pump storage, etc. So these all elements would also be, I mean, with the increasing need for the power supply contribution. So these things would also be, I mean, required in the overall macro level things. Besides this, I think a very important aspect here would be if we can have something in line with, we already had an impact assessment tool of a smart grid which was developed by ma'am and the team earlier for the smart grids. So on similar lines, if we can have a standardized framework for evaluation of these smart grid projects from the ESG perspective, because ESG nowadays, I mean, it's an important perspective which we have to see even when we go in for raising funds outside India especially. Besides that, I think we are already testing the PPP model in the smart metering. It's started to off-take now under RDSS. On similar lines, at least we can at least look at having a PPP model for the grid modernization aspect also. Something on these lines is being tried, like what Mr. Sharma said, is being tried in Rajasthan, where they are trying to do feeder solarization and segregation on a hybrid NVT model. Right, so that is something different from the conventional capex-based funding. As far as the regulatory aspects are concerned, I believe what Mr. Nataraj also pointed out, I mean, there is a need for the change in stance by the regulator. There needs to be some regulatory sandboxes so that the DISCOMs are not reluctant to try the new technologies. As of now, what is generally seen is most of these costs are not approved by the regulators, so the DISCOMs are not very willing to take up the challenges, and they do not go beyond the pilot stage. Right, as far as the financing side is concerned, I mean, we at PFC or otherwise, I think an important financial instrument which is being looked at nowadays for technologies which are presently being considered non-commercially viable, or I'll say they have a long payback period, is something called blended finance, which would have the normal finance coming in from one side and the concessional loans or grants coming in from the other side, and then the two together can put in and we can have a blended finance product which can help reduce the payback period for such technologies like green hydrogen, then again pump storage or any other such project. Besides that, I think these fundings can also come up from some alliances, like we have one which was recently announced in the G20 Global Clean Power Alliance, which was recently announced, right? So, I mean, these alliances can also put in some kind of a support which would further add on to the funds which would be used for offering a better concessional product which will have a better payback period.
Thank you so much. So to summarize it, basically you talked about policy incentives, financial incentives, you talked about blended finance, tools such as the standardized framework for evaluation of smart grids for ESG perspective, PPP model and grid modernization. These are a few examples which you have given. Moving on, now I'll come to Kumar. Going forward with the smart meter rollout only, if I talk about the West, including UK, the Western countries have the DNO and the DSO system, which is the distribution network operator and the distribution system operator system, which along with the smart meter rollout has helped in retail supply competition, develop the retail supply competition. Can such examples be replicated here, and if so, what do you envisage as the pathway or immediate steps, or maybe the roadmap to take this forward?
The DNO and DSO model, as you mentioned, are really required for our country as well, in maybe not near future, but in some time in the future. And the pathway for adoption of this model would be that first we need to have a separate business unit within the distribution company itself, which takes up the role of DSO. Role of DSO can be taken up even without separating it as a different entity. So like we again taking a cue from the transmission grids, earlier we had this grid monitoring within power transmission company itself. So similarly, we can have DSO role within the distribution company, wherein a dedicated team of functional experts as well as IT experts or data experts can be sitting together and continuously monitoring and watching what is happening in a localized manner in that area. And it should be at a different scale. It cannot be at the distribution company's level. It can be at the level of maybe a city, wherein or maybe different sub-centers should be established in the country. Because if we see the number of customers which are served in maybe say UK, vis-a-vis the number of DSOs which are working in that network, it will be way beyond what we will need in our country. So it simply cannot be few distribution companies serving millions of customers and also few distribution service operators serving so many generating stations, because consumers will become prosumers. So they need to be managed as well. We need to figure out where the distribution network bottlenecks are there. Do we need to give some incentives for customers for demand response so that the peak load is served in an optimal manner, or do we need to give some incentive for the prosumers to not feed back into the grid but to store in their local distributed storage, which can be battery in their own premises. And let me tell you, in India, many of the households already have battery available as part of the inverters which are there, because in India 24/7 supply in all the cities is still not there. Maybe we have improved a lot. The number of hours has improved from earlier days to nearer to 24 hours, many part of the country. But still, people do have inverters or backup supply in their own premises, just in case there is some breakdown or outage from the distribution company side. So those kind of things can be handled better if there is a separate role in the distribution company, because as of now, if we go and interact with some distribution company, they will simply tell that IT team is responsible for all the gamut of activities that are behind the data which is getting generated from the smart meters. So any problem with smart meter is IT's problem, but which it should not be like that. Smart meter is again part of the operations process. So operational team is also to get engaged with the smart meter and the data to take operational decisions. So a few days back in the GridCon, there was a paper presentation about maybe distribution grid imbalances which are detected based on data analytics of the smart metering data. I simply put a question: is there some action based of those data insights? So that is still not there, because buy-in from the functional side, buy-in from the operations team is still not there. Maybe because they are not fully aware of the benefits that can be there for managing their, again I said, pain areas are to be addressed. So we need to connect and communicate in a manner that those people also come on board and start putting data into action. That is foremost important to begin with. Once we start putting those things in action, once we start improvising the distribution grid management based on the data that is available, improvise the data that goes into the system, data availability, data integrity, all those aspects are also critical. Many times we find that the smart metering data is not available as per the SLA requirements, and the challenges are passed on to the maybe say that ऐसे क्या कस्टमर क्या सर्वे क्या बोल रहे हैं आप? Okay, maybe because people have not really done that consumer mapping to the network in a proper manner, or maybe because the telecom service provider is not giving the services in an optimal manner. But we should, then if data is not available, how we are going to decide that the imbalances that are discovered by those data analytical insights are really pointing to the right figure? So data integrity is equally important. We need to take all out efforts to showcase the value by low hanging, by small pilots wherein integrity of data is also there and people are really able to analyze the benefits. So then that can be replicated across the city, across the distribution company, but we need to have multiple such centers, in my opinion. And for DNO network, again, segregation of content and carrier will be there. For competition to be there in distribution sector, financial viability is important. But like it's a chicken and egg situation. Financial viability will be there once we start putting data to action, and once financial viability is there, then the competition can be foreseen. So that is my take.
Thank you so much, ma'am. So just to summarize, the key takeaway would be a separate business unit in DISCOMs which take up roles within as DSO, and for DNO we need to have financial viability, which is very, very important. And of course you talked about data integrity. So now coming back to the policy angle, and since we have Mr. Vadvan here, we would like to know your thoughts on the successes and learnings of the RDSS scheme. And with the scheme now getting extended for the next 2 years, would there be additional focus areas? And how do you see the DISCOMs benefiting further?
Yeah, thank you, Sanyukta. So first and foremost is, yes, I mean, the scheme, we've seen many positives coming out of the scheme so far. Yes, there have been delays in the implementation, which were like what ma'am also just pointed out, because we are dealing with multiple stakeholders, and as I'll say, I mean, it's an 18th century poet pointed out कि बस के दुश्वार है हर काम का आसान होना, right? So things are not so easy to be done. I mean, when you have multiple stakeholders involved. However, I feel, I mean, from the regulatory and the financial discipline perspective, we've seen quite a few good things which have come up, which were not there in the scheme. I mean, the scheme envisaged not just the funding from the project's perspective, it also required the DISCOMs to also implement certain pre-qualification or the pre-disbursement criteria, which we are seeing more or less being fulfilled. So that has been a positive side. Besides that, I mean, slowly but steadily there has been an offtake of the smart meters also, and we've seen 20 million smart meters already being installed in the country as per the present numbers, right? So yes, I mean, what you just pointed out, that there have been news articles around an extension of the timeline for the scheme. So I may not be in a position to comment on that, but having said that, I think going forward, once this offtake is I mean, increased with respect to the smart meters, as well as there is, I mean, a parallel integration of the rooftop solar, which is being done under the PM Surya Ghar Yojana, along with the other modernization aspects being covered under the RDSS scheme, like the smart distribution projects, the SCADA automation projects. I think a very important aspect which will have to be touched upon going forward would be the effective usage of the data, as ma'am also pointed out, and the appropriate analytics to work on them. Right. So, I mean, with the ever increasing load in this country, I think there is a requirement for a proper load forecast, peak management, then RE integration, obviously. Besides that, the network optimization and the load flow analysis. These all have been tried, but I think with more and more data, I think it can the issues or the lacunas that have been there earlier, they can be ironed out, right? Besides that, I think there can be work. We can work on there's a chance of working on. There's a good opportunity of working on the new technologies like digital twins. Besides that, predictive maintenance, that is something which we, under the Aspire program, it was already tried using the drones for 2 feeders in Maharashtra, right? So these kind of aspects can definitely be looked into. Besides that, I think the one very good initiative which has come up, and we just launched it, it was also launched on the IGOT portal, which is the Distribution Utility Manager program, right? So similar capacity building initiatives, because again, I mean, what I also said in my inaugural speech, that, I mean, this aspect of people being touched is also to be seen, right? I mean, I mean, the consumers are to be focused, and besides that, consumers are again, I mean, what it was also pointed out that, I mean, that consumers are to be focused, and besides that, I think the people of the DISCOM, right? So they also need to learn and unlearn and again learn, right? Because with the change of technology, we cannot have that old mindset to be continued and have the old hands working on the new technology, right? So these would be the few aspects, some good takeaways from RDSS. Besides, these are the aspects which we feel would need to be continued under RDSS as and when the scheme is extended.
Thank you so much. So basically, taking forward the work, already the good work which you were anyways doing, such as load forecasting, peak management, network optimization. Apart from that, new areas like digital twins, predictive maintenance, and a key focus on capacity building areas. So going forward now, I have a common question for both the UK companies which we have here today, and maybe we can start with Dr. Ashutosh, and then we can come to Flock, Mr. Sharma. So the question basically is, firstly, what are the varied AI and ML technologies internationally which would be useful to make the grids future ready in India? And what is the biggest barrier you see for any international technology to be implemented in the Indian context, and how do you or your organization try to overcome the same? So we start with Dr. Ashutosh first, and then maybe we can come to Mr. Sharma.
Thank you, Sanyukta. And another very good question as we have raised here, because there are several AI and technologies internationally that has been now validated and proven that will help India to have India's grid future ready scenario. Now, let's understand this entire context, because now India, as we said, as you've been during this thing, it's been mentioned, the hunger has increased, 400 gigawatt has to be achieved by 2030, an additional energy requirement. What has been happening that the assets all across India, they are now aged. Now, these assets are aged. Now, new RE integrations are in place, and that demands to have grid modernization, and additional costs are there for infrastructure costs. And all this thing and the increase in the energy demand. So all these things start to come to the point where it starts to pinpoint, as Mr. Komaljit Wadhwa also pointed, that it has to come in being future ready, certain aspects have to be considered, that where this entire thing can bring in as finance as well as regulator and the technology. But I'm here right now to speak about the technology part of it, how that will be helping. So we need to see that what we need to be there is focusing on the asset management and maintenance, and very specifically predictive and precision asset management is very crucial in this case, because that will help to the use of AI and machine learning to benefit. We can just use the technologies to then help to monitor the grid components and the health in real time. As also Mrs. Kulud Wadhwa was saying, that there should be some nodal points where the data that has been collected, it needs to be given in a better possible way. So the more actionable items are needed rather than just giving us general analytics that will be there. So that is one thing. Another challenge that we definitely see is the machine learning models. Now, this mindset is something that we have to also understand, because very often we have spoken to utilities and we see that because there's a lack of framework, lot of utilities, they start to focus on saying that, okay, we will start to go ahead and start building our own AI models or machine learning models because we are in a different geographic location. But please understand, if I give an example like for the airline industry, if Airbus or Boeing, they start to say that, okay, let me start to build every component, the engine by myself, by the other components by themselves, it would not make to that level of expertise. What we have to focus is that if there are companies which are focusing in companies like ourselves in AI, we've been focusing in different predictive analytics solutions. Now, we have been learning a lot of things, not just from the Indian context, but there are other geolocations. For example, if we see in New Zealand, they have similar things that are in some parts of the Northeast India. There were certain desert climates in Saudi Arabia. That is there in the western part of the country. So our system models have been learning quite actively. So what has to be a very clear mindset is that how to adopt that thing into the real thing, so that you as an the utilities which are experts in operating and maintaining, they focus on that, whereas the companies which are this should be more like a interdisciplinary coaction between the systems that they can help each other, where the utility companies will focus on repair and maintenance and deliver the 100% availability, and then focus on the reliability and then achieve the resilience. So that will be a systematic and strategical alignment and road mapping for the long, bigger goal picture that we see. So that we definitely see. The other challenge is that renewable energy integration, as you said, the AI and machine learning technologies will definitely help to make that ease in integration, because if we just keep constantly, as Mrs. Kumud Vadhva was also mentioning, that there are new distributed energy power centers. Now they are to be connected into the existing system. So that becomes quite a challenge, because there will be a lot of things have to be balanced in the entire system. So this is one thing will happen. Then, as I said, systematically going for the grid resilience, because there are a lot of things that are happening in the global warming and other impacts are we are able to see. As you might have been seeing lots of news lately in Saudi Arabia, all of a sudden there's so much of heavy rain and floods that have never been seen in the past. Or other way around, like in India, we have been seeing lots of stronger storms or landslides, etc. They are becoming a more frequent thing. So again here, AI and machine learning algorithms or the technologies that can help in enhancing the grid resilience against the natural disaster and other contingencies. Then I would say last, in my opinion, is again using AI and machine learning technologies that definitely help in the grid optimization and control. Because in the real-time monitoring and automation of the operation of the grid, this becomes quite a crucial thing, because with the experience that was being cited, and also we have seen that in an optimal flow of energy and the grid stability analysis is very important and has to be in a real time. But at the same time, this information has to come not just based on the mindset, what Mr. Kamaljeet Vadhva was mentioning, that people have to unlearn, learn, and again learn new things, because this is where the mindset blocks them. So this needs to be very clear that there is a mindset that my linemen have a 20 years of experience and they're able to do certain repair work, or my engineers have this thing. But please understand that AI is also learning and bringing the artificial intelligence and bringing those extra knowledge into the system. That is constantly growing. So, for example, in our case, like our intelligence, we equate that to almost equal to 170 years of man intelligence now. But if this is just based on the man intelligence, like human intelligence, if a person has come to a retiring age, let's say 60, and he has spent 40 years of his life experience in this particular thing, but the moment he superannuates and a new person comes in, so that gap now, instead of growing further on, now the new person has to take up the challenge, because now he is younger than the other person, which is definitely a good thing. But at the same time, he needs to now to take up new challenges now with that experience that has been built up, which was from the other thing. So this is where we want to bring as a coexistence, where technology becomes like a helping tool with the existing system, so that the new generation of the energy operators or the system operators, they utilize this tool of an AI and machine learning as an additional tool that will help them to then improve the efficiency of the system and the grid optimization and to control in a better. So that is where I see these things will make more as an impact.
Thank you, Dr. Ashutosh. So asset management, predictive management and machine learning, a few of the areas which you rightly pointed out. Mr. Sharma, if I can ask you the same question and your opinion.
Yeah, I think it's difficult to answer the same question after an elaborate answer from Mr. Ashutosh, but I'll still try. So the technologies, AI ML technologies, are going to change the energy industry for sure and across the entire value chain. So starting from transmission, generation, as well as what's happening behind the meter, understanding the customer, all of these aspects are going to be impacted. We talk about deep learning methods, deep learning technologies, machine learning. They're going to improve the way we are forecasting our renewable generation. Real-time data around satellite, real-time data around clouds is going to play a very critical role in understanding what the generation is going to look like. Like ma'am was mentioning earlier in the conversation, I think the real-time time of use, pricing, and all of these things are going to play a very critical role as well. And that's where, to enable all of these, AI ML are going to play a very critical role. We see transformers as a big issue in the entire energy industry. The ETA for getting a new transformer is anywhere between 24 to 48 months. So how do we make sure that these transformers are up to date and they are not bursting every now and then just because we didn't predict the demand well? So all of these issues are going to be circumvented by the advent of AI and the implementation of AI and ML in the overall operations that utilities are going to have. Now, more interestingly, I think the biggest barrier that we see as a UK company coming in India and trying to help out utilities and build a business is definitely with regards to data. So similar to how Indian economy evolved, we directly moved from agriculture to services industry. We kind of missed the hoop of manufacturing. So we believe that frankly, that's what we are seeing in the energy sector as well. We are directly moving from limited amount of data to roughly 25 billion data points on a daily basis if and when these 250 million smart meters are deployed. So do we have the required data infrastructure? I would be very cautious about it to say that we do. And so that's going to be a major challenge. How do we store this amount of data? How do we manage this amount of data? Because even AWS is not managing 25 billion data points on a daily basis. So it's going to be by far the largest amount of data that any single entity or nation would be collecting on a daily basis. So which is going to be a challenge. Just to give a particular example, like Mr. Ashutosh rightly pointed out, I think there is a lot of goodness that we can derive out of some technology that are being developed in US or UK, because we already have the underlying model. It's just about localizing that model with local data and local constraints, which I believe not every utility should try and do on their own. They should use the goodness and the model that has already been built by companies like Vidrona and Flock Energy, and try to just customize these solutions in the best manner possible so that they can get the goodness of years of research that has went behind it. I'll stop there. Thanks.
Thank you so much. So data infrastructure is one of the barriers which, sorry.
Yes.
Okay, yes, Dr.
So
Ashutosh.
I just would add one just point along with what Mr. Sharma said, that, what I definitely see as an additional thing, that, while the utilities or other companies try to invest in trying to build something on their own, what would be good is that, that surplus cash that is there, that can be put into another funding agency where, like, organizations like PFC or something, that they can monitor that and say that, okay, this is the budget that we have carved out and this is what we are trying to make it happen, because we see that these kind of things also would impact additionally. So because that would be the strategic alignment on the thing that Mr. Sharma also mentioned, that would be a more productive way of adopting newer technologies, especially for the need for the India's such a big country which would need all these things into place. So, sorry, that's what I wanted to add. Nothing more.
No problem. Thank you, Dr. Ashutosh. So in the interest of time, I would now close the session because, yes.
Just taking a cue from whatever discussion we've had, I think another aspect which would be finding the very core of its presence going forward under RDSS and besides RDSS also would be cyber security. Right, I mean, I missed out on that point, but I think with more and more data points coming in, more and more technology interventions coming in, we're also talking about peer-to-peer trading, we're also talking about the other aspects like machine learning and all. I think cyber security aspect is something which we would need to learn from the other countries. They may not be absolutely be fitting into our kind of infrastructure or our kind of an architecture, but yes, I mean, we can always take cues from them and try to customize those as per our requirements.
Thank you, Mr. Wadhwa. So if I have to close now, because in the interest of time we are running, I think, almost a session late. So today's discussions has highlighted the critical role of future-ready smart grids in India's energy transition. We discussed how digitization, energy storage, policy reforms, and cutting-edge technologies can create a more resilient, efficient, and sustainable power network. There is need for technologies like digital twins, as Mr. Wadhwan pointed out, cybersecurity, predictive management, machine learning, incentivization and regulatory flexibility and financial flexibility. As the country moves ahead towards achieving its RE targets and collaborating between policymakers, industry, and technology innovators will be key. Investment in smart infrastructure, proactive policy measures, and a focus on grid flexibility will define the success of this transition. And ultimately, the goal is clear. We have to build a power grid that is not only robust and adaptive, but also enables a cleaner, greener, and a more inclusive energy future in India. Thank you to our esteemed panelists and the engaging audience for being a part of this conversation. Thank you so much.
I would like to invite Ms. Reena Suri ma'am to come up on the stage and present mementos to the speakers. Ms. Kumud Wadhwa. And Mr. Ankur Sharma. I request everyone, please come forward for a group picture. Please come forward for a group picture.